Yes, very good morning.
Good morning, sir.
Good
Yes,
morning, sir.
yes,
Good morning, sir.
yes,
Good morning, sir.
yes. We will wait a few more minutes. Yes, my slides are visible.
Yes, sir.
Yes, sir.
Yes. For today's class, we request some people to join with us till the end. Yes, 31 to 40. Serial number 31 to 40. 66, 64, 66, 70, 72, 74, 76, 78, 80, 82, and 84. You please unmute your mic and you please join with us till the end. Karthikeyan?
Yes, sir.
Yes, Karthikeyan. Chandrakant, Madan, Maitreen, Dinesh, Varun, Sai Ranga, Patil, Marila, Pranish. Yes. Yes, this is what we have seen yesterday. And we were discussed about the PV cell and the things which is apart from the PV cells were discussed earlier. And at the end, we were introduced the wind energy and the basic information we were discussed yesterday. And uh, we continue with the yesterday's presentation that is we were discussed about rotors and transmission system, and there are five different nomenclatures we need to reveal concerning the wind turbine. And yet we didn't disseminated the types of wind turbine. There are usually there are two different types of wind turbines. That too depends on the axis of the wind turbine. It is classified. Either it might be a horizontal axis wind turbine or it might be a vertical axis wind turbine. This is what the example of horizontal axis wind turbine. And there are five different things we need to discuss about these wind turbines. One is rotor, the second one is transmission system, the third one is generator. We know that generator which was coupled with the shaft. The shaft is the various wings or leaves are mounted on the shaft, and the shaft is connected to the gear. In order to elevate the number of revolutions, we are having gear and gearbox. And the generator is connected with a smaller gear. In order to increase the RPM, we were connected these generators with the smaller gears, and so that it is feasible to increase the RPM, which is very minimal when concerning the main shaft. The generator usually converts the mechanical motion of the rotor to the electrical energy, and which is working on the principle of electromagnetic induction. When an induction conducting coils rotate in a magnetic field, therefore voltage is generated across the coil terminals, which becomes the source of power. A generator of a grid connected wind machine is required to produce the frequency which is same as grid frequency. That is that should be 50 Hz usually in India. The generator can synchronize generator. There are two different types of generator are usually used in these type of wind turbines. One is synchronous, the second one is asynchronous. A synchronous generator provides constant frequency output, but on the other hand, it won't allow the rotor speed variations. And an induction generator which can supply a constant frequency output, but while allowing some variation in the rotor speed, it can allow the variation in the rotor speed. The generator power is first converted to DC, and then back to the AC power of desired frequency. And the fourth system is yaw system. The horizontal axis wind turbine have yaw system that turns the rotor according to the wind direction. When we are mounting in one particular direction, then it won't be any useful as when we have the wind at different direction. Therefore, it has to the base has to rotate, not to have a rotation over the turbines. The base has to rotate. The base system is called as the air system. A rotor swept area should be moving perpendicular to the wind direction. In that way, the yaw system is arranged, and the yaw system is also used to cut off the rotor from the wind in case of very strong wind. And this is done from the point of view of the protecting the entire system. And the last one is tower. The tower on which the turbine is mounted is not just a support structure, but it also rises the wind turbine so that the blades safely clear the ground, and so it can reach the stronger winds at higher elevations. And the maximum tower height is optional in most cases. The except where zoning restrictions apply. Usually, the height would be ranges from 40 to 70 meters, and the tower in a large wind machine in hollow from inside, which provides the access to the nacelle for maintenance. And there are some calculations available to find the optimum height. And as the height from the ground increases, usually the wind speed increases. The decision of what height tower to be used will be based on the cost of the tower per meter, which increases in height versus the value of the increase in the energy production resulting from that use. And typical example of various turbines, and the single blade turbine, the double blade, and then three bladed, and multi bladed, which is designed by US, and bicycle type of multi bladed turbine. And the wind direction, based on the wind direction, it is classified as an upwind or downwind. and we have Enfield Andrew type of wind turbines and sail wing, and even the multi-rotor type of wind turbine is also mounted in some particular places. The counter-rotating blade and the cross winds 7As. The 7As we were discussed about the 7As type. And the subsequent type we can overview about the 7As. The cross wind paddles, diffuser, concentrator, and unconfined vertex. And see, this what the general classification of wind turbines. The first one is horizontal axis wind turbine. The all the three other three are classified as vertical axis wind turbine. The whether it might be 7As, this is called the 7As type, and Derisius and H rotor. All these three wind turbine are classified as in vertical axis because the axis will be vertical. Therefore, these are classified as a vertical axis wind turbine. And see the pictorial representation for the photographs of these horizontal axis and vertical axis wind turbine. See some other examples related to various other wind turbines. See here, this is the fourth case, that is H rotor type wind turbine. This one, and these are also related to H type. See here, there are a heavier structural arrangement is provided at the top. Usually, in the case of two-wheelers, we know in the diesel engine, we were disseminated some stokes related to diesel engine. Usually, the four-stroke engine, we have the power at the third stroke. That is, these stokes are classified in the following way: whether it might be suction, compression, expansion, and then exhaust. The power usually we can obtain the power at the end of the third stage, and at the beginning of the fourth. That is during the fourth stroke alone we avail the power, and for the rest of the other three different strokes we need to have power. Therefore, what we can usually do, we usually provide a structure in order to drive, in order to get the power for other different three strokes. That is usually called as a flywheel. See here the same system provided here. A long structural arrangement is provided in order to have a rotation in the subsequent. When we have the wind flow, at that time there won't be an issue. When there is a drop in the wind flow, there is a drop in the wind velocity. During that time also we need to drive the system. Therefore, these flywheel arrangement, these driving mechanism leads to have the power even there is a drop in the wind velocity. And the thing is, the issue with these structural arrangement is the initial torque should be maximum, not because this system has a very heavier arrangement. Therefore, the initial torque of the initial velocity of the wind should be more. And see the rest of the uh, different types of wind turbines. And here there are the vertical axis wind turbine alone presented here, and this is what the various nomenclatures. And already we were discussed till see here the yaw drive system, yaw mechanism is clearly shown here. When there is a change in the wind direction, this will change the direction, and through the wind vane we can get the data, and anemometer is provided to measure the wind velocity here, and through that we can change the direction of the turbines, so that we can get the maximum power from the respective directions. And the other nomenclature, see the long shaft is provided, and the various leaves are mounted on the long shaft, and the shaft at the end, we have the gearbox, and by transferring the power from the longer gear to smaller gear, we can increase the RPM. These smaller gears are connected to the generator, and the generator, through that we can get the power. The generator and then we are getting the power. We are having the controller, and the entire system, entire arrangement is provided inside the nacelle, and that's all about these nomenclatures. And see the horizontal axis wind turbine and then vertical axis wind turbine, and this is what the swept area. The area covered by the rotor blades are called as an swept area, and rotor diameter is provided here. The wind direction, that is upwind, and here we have gearbox, generator, and the system is provided inside the nacelle. And see here, this is the type of vertical axis wind turbine. Here we have the gearbox at the bottom, and we have the rotor base, the fixed pitch rotor blade, and the rotor diameter, and the rotor height, and the equator height. And see, this is what I have in the yesterday I have sent a link for knowing about these various traffic powered wind turbine. Still this is out of scope. Anyway, you have a look on these type of traffic powered wind turbine, and this also one type of traffic powered wind turbine. And see, okay, we'll discuss about the various advantages and disadvantage of the wind turbine. And concerning the advantage, and the wind energy is renewable source of energy. It is free and inexhaustible, and it does not take long time to construct. And the power requirement for irrigation, lighting, and small industrial units can be fulfilled with the use of wind energy. The wind energy has a bright future. The use of small aero generator producing about 500 watt is sufficient to power a house of one family at a reasonable cost. This will definitely attract the Indian villages for a good standard of life, and it does not need transportation. And concerning the environment, it is pollution free. And on the other hand, it has various demerits, and wind power is not consistent and steady but fluctuating. Therefore, designing a windmill components is complicated, and the selection of suitable materials is a major issue concerning these designing, and the wind the materials would be the appropriate selection of materials should be very conscious. Some form of storage of wind energy is essential to maintain constant supply of power. A technological breakthrough in energy storage alone can create a favorable situation for its use. In particular, in India, the wind is very hazardous and tertiary and even unpredictable source of energy. So it may blow in strong gusts from varying directions, causing hurricanes, and thus the wind may smash the whole plant within no time. So to avoid this, a special and costly design and controls are also required, and it is considered economical to generate power on a small scale of the order of 5 megawatt only. The power production cost may not complete with the conventional power plants. The thousand of windmills units are required to provide the power outputs of one thermal plant. And that's all about wind turbine, wind power generation, and the rest are basics. Do you have any doubts with these? Do you have any doubts? Anyone please unmute your mic and tell me. Dinesh,
No, sir.
Dinesh, Varun.
No, sir, no doubts.
Yes. Yes. Oh, okay. What was the current affair? We'll discuss the current affair and then we'll continue the session. Yesterday, Maitreyan initiated about the black fungal See, it was the major issue today. Even the doctors are concerning about even white fungal also. And anyone you go ahead with the those contents or any other matter. The session is open to you all.
IMD warns over another cyclone in Bay of Bengal, which may hit the coast of Odisha on 24 May.
Oh, pardon, Subham Kumar.
Sir, IMD warns another cyclone in the region of Bay of Bengal, which may hit
Oh,
Odisha coast on 24 May.
oh, 24th May.
Sir, and yes, yesterday like some like people who went to like rescue team, like they got like the ship broke in the ocean like 175 kilometers from the coast, and like to rescue them another team went, sir, like because of the storm and all.
Oh. Yes. Yes.
And
Any
then
other?
like there's also this like they're planning to like close all the festivals from June or something, sir. That's like they're thinking like because of the festivals, the COVID cases might increase, or like like they're telling that they might ban all the festivals that are coming after June or something.
Yes, see, this is what the things which is done by the government. See, five different states conducted the elections. See, due to these government won't accept based on these the elections, the number of cases elevated, the government won't accept. And what happens? See, they will interfere with the religion, and they wants to curtail those celebrations. Anyway, we will accept, but if there won't be any elections during during past, definitely the number of cases identified would be in the decline state. At that stage, there won't be any need to curtail these celebration and all. And that is what the government did past. And yes, no, we need to accept those things, and accordingly we can reduce the number of identified persons in COVID would be minimal in near future. And any other Dinesh, and Varun. Dinesh is already Subham Kumar and Maitreyan, and people like Pranav are already discussing various issues. You unmute your mic and discuss about any other matter. Dinesh and Varun. Dinesh,
Yes,
Varun.
Yes, sir.
Yes, one by one.
sir. Black fungus is announced as epidemic in many states.
Yes. Varun. Okay, we'll discuss Varun. Varun.
Yes, sir. Yes, sir.
Similarly, white fungus also has been found, but whenever it shows the symptoms of COVID itself, but whenever the test has been like taken PCR whatever, it showed a negative. So because like white fungus attacks the lungs particularly, and it can be diagnosed only after taking CTs and MMS test, and apart from that. Also, Spain have been like conducted a study where with using AstraZeneca and Pfizer, and after that they have found that using the both doses like increase the efficacy rate.
Yes. Yes, but it is very panic.
And sir, like even in Patna, sir, yesterday a new variant of fungus was found. It is called white virus.
What? Which virus? What was the name?
White fungus, sorry, sir.
White fungals. You are talking about white fungal. Yes, yes,
Yeah.
yes.
And
Yes,
sir,
see, these fungals are not new for us. We were already aware about these fungals, but concerning in particular with the COVID patients, now those who are recovered from COVID, they are affected a lot by
yes, sir,
these.
like, those having less immunity power are affected,
Yes,
and this is causing problems to them, having COVID earlier or having right now.
yes, yes, Varun. Varun.
And last
Yes,
week
sir.
there was many dead bodies floating in Ganga River. And present this week, what happened? Many dead bodies were buried inside the land of Ganga, sir.
Is what was the name of that particular function, Bhavya?
Sir, it is not that function, sir. It's due to this COVID patients. They're
Sir,
throwing this like.
in my district itself, like 73 dead bodies are found floating on River Ganga.
Oh.
Yes,
In
and
particular, in your
many
state,
places, yeah.
in your district.
Yes, sir.
Since they cannot bury it, they are just like throwing it inside the river.
Oh,
They just throw it in the Ganga River, sir. Like throughout
Sir,
the Bihar, it has been found.
due to that, this water get polluted. And one more thing, this COVID spread is very high in that area, sir.
Yes, it won't be, but see, there are if the condition is very bad, and see, even they are not doing the final funeral also, and they are instead doing burial, they are simply throwing away. That is very unfair. Yes, yes, Varun. Varun, shall we solve one puzzle, Varun?
Yes, sir.
Okay. I'll give you the puzzle, but these puzzles you can find in the web, and don't Google it and tell me on your own. A person crosses 600 meters in long street in 5 minutes. A person crosses a 600-meter long street in 5 minutes. What is his speed in kilometer per hour?
7.2 kilometer per hour, sir.
Pardon?
7.2 kilometer per hour.
Yes.
7.2 kilometer per hour, sir.
Yes, Varun, tell me the calculation. How you derived it? It was right. It was right.
600 meters in 5 minutes means 300 seconds, sir. 2 meter per second.
Okay.
1 meter per second equal to 3.6 kilometer per hour. So into 7.2 kilometer per hour, sir.
Yes, very good. Okay. In order to get these type of puzzles, what was the site you usually refer?
Sir, I don't refer any site, sir.
Yes. Anyway, I'll tell you. The IndiaBix is a very good site for getting various puzzles and various MCQ. See, this is what. Yes. Yes, this is what the basic formulas in order to remember during the solution of time and distance. See, it is very minimal. Only 5 formulas are available now to solve these type of puzzles. Speed and kilometers, and see, suppose a man covers a certain distance at x kilometer per hour and an equal distance of y kilometer, but then the average speed during the whole journey. Okay, with this I'll inquire some other questions with some other people.
Thank you, sir.
Yes, Chirag Bhatia. Chirag, are you ready?
Yes, sir.
Okay. Okay, Chirag, if a person walks at 14 kilometer per hour instead of 10 kilometer per hour, he would have walked 20 kilometers more. The actual distance traveled by him is what? A person walks at 14 kilometer per hour instead of 10 kilometer per hour. He would have walked 20 kilometer more, and the actual distance traveled by him.
50 kilometers, sir.
Yes, yes. Who said 50 kilometers?
50 kilometers.
Who said? Chirag? Whether this is Chirag or Kadam?
So me Prathamesh Kadam.
Prathamesh Kadam. Very good. Very good. How Prathamesh?
Sir, 10 kilometer and 14 kilometers. So basically for each hour, there will be 4 hours difference, sir. Like
Okay.
in 1
Okay.
hour, 4 hours difference will come. And you said 20 kilometers. So it will be 5 hours in total. So we know the time, we know the speed. So distance, time into speed.
Yes, very good. Very good. That's all. That's all. Very good. Okay. With these lines, what are the difference between speed and velocity?
So velocity is speed in a particular direction, sir.
Very good. Very good. Okay, you are driving a car with 60 kilometer per hour. Then what is speed and what is velocity?
So speed is 60
Sir,
kilometer per hour and velocity is 60 kilometer per hour in that particular direction.
sir, like when you're going in a shortcut, it is velocity, sir. When you're going like your own path, it is called speed.
Pardon my brain. Pardon?
So displacement per time is velocity, sir. Distance per time is speed, sir.
Okay,
So
then
if you
then
take,
what was the difference between distance and displacement?
so displacement is shortcut, sir. Like straight path to your end
Shortest distance
destination.
between 2 points, sir.
Very good, Nitish. Very good. Okay, okay. Then which one is a scalar and which one is vector?
Displacement is vector, sir. Distance is scalar.
Okay, very good. But in the case of speed and velocity,
Speed is
Velocity is
scalar, velocity is vector.
yes, very good. Yes, 60 kilometer per hour would be speed. 60 kilometer per hour towards north or south would be velocity. Very good, very good. Okay, in the same line, we have various puzzles. We'll continue those puzzles in the subsequent class. And we will continue the rest of the things which is in wind turbine. Any other matter do you want to discuss? Any other issues? In the
So
same
like
way,
for wind,
yes, Maitri.
so wind turbine, they found like there's this Alterios company, sir. Like they found a wind turbine which like floats in the air. Like it's a balloon with wind turbine, and it's used in Alaska, sir. Like you can like see about it, sir.
Yes, yes. You collect those details. Will give forum for you to discuss. To collect those informations, the advanced titles and all. At that time, you can present those things, Maitri. Do you have
Okay,
picture for that? Do you have any pictorial representations?
sir. Like you can like check in Google, sir. Alterios airborne wind turbine.
No, Baya. No. For knowing me, it won't be matter. For knowing others, also 59 would be matters. Okay, anyway you collect it. I'll give you time. At that time, you can share those contents to your friends.
Okay.
Yes, and in line with the past discussions, there are so many discussions may continue. See, we were discussed about the difference between distance and displacement, speed, velocity, and then acceleration due to gravity, and through that we need to approach the basic law, and then we can extend our study to the Newton's laws of motion and the difference between mass and weight. And with that, we can start journey with the basic mechanics. And I think you're in the present semester you're having mechanics, right? Soil mechanics, and you're studying mechanics in the present semester.
Yes, sir. Applied mechanics.
Yes, yes. Yes, okay, good. Okay, we'll continue our session. And this was the windrose diagram. The strong wind usually come from the particular direction, and to show the information about the distribution of wind speed and the frequency of the varying wind directions, and one may draw a so-called windrose diagram is represented here on the basis of meteorological observation of wind and wind direction. See, the it was in knots. It was in knots, which is the 23 greater than 23 knots, and which varies from 70 to 22, 11 to 16, and this was the direction, various directions, and with that we can find what was the wind, and with respect to the frequency we can identify, and based on these data we can the installation may be feasible. And see, due to the uneven heating of the earth by sun rays, and there might be changes in the wind pressure. And see, this, the south pole and north pole and the equator given here, and the sun energy falling on the earth's surface creates larger scale motion on the air due to the uneven heating, and which rising air at the equator moves southward as well in northwards, and these motion of air stop when air cools down at about 30° north as well in the 30 degrees south latitude. And these latitudes, air begins to sink down and flows towards the equator through lowest layer of the atmosphere, in which way the air completes one cycle. Therefore, the motion of Earth around its axis has an effect on the direction of the wind flow, and the factors affecting the wind speed and direction are one is the heating and cooling rate difference on the Earth's surface and seawater, and the presence of the local obstacles like trees, buildings, mountains, and valleys. Even these things also will affect the wind speed and the direction. Therefore, and this was the vertical wind speed variations at a given location. The wind speed increases as we go above the Earth's surface. We go up, or upwind speed increase more rapidly at lower heights, but less rapidly in the higher heights. The vertical variation in the wind speed depends on the roughness of terrain. See, alpha is a constant and wind speed near the ground. See, this was the calculation of the wind speed, and alpha lies between 0.01 to 0.3. In water areas like sea, the alpha would be 0.01. In the farmlands with the trees, it is alpha is equal to 0.12. In villages and town also it seems 0.12, and we can calculate the wind speed at unknown height is equal to v at the known height, the velocity at known height, and the just a minute. And therefore we can calculate the wind speed at the unknown height based on the known height, and v at known height into new height divided by the reference height par alpha. The alpha, we know the alpha value based on the area it is decided, and the new height is the height at which the wind speed needs to be estimated, and reference height is the height at which the wind speed is known. And for the typical vertical variation in the wind speed, and Wind speed of 10 meter per second is considered at 10-meter height from the ground. See, this was the wind speed meter per second and the height in meters. In 200 meters, what happens? In 200 meters, it would be around 11.7 or 11.8, and when it was 400 meters, it will be in 13.5. And the distribution of wind speed at a given location, the wind speed varies over a day and over different season. The power extracted is depends on the cubic wind speed. A histogram presents the probability of the wind speed to be certain limits. It can also be presented in the form of number of hours. That is, we have the in total we have 8,760 hours in the year, and this is what the histogram and the typical wind speed data of a location as function of number of probable hours of a given speed in the year. Wind speed histogram. This was the wind speed histogram and wind energy hours per year. And at the during the 10th hour, and it was the peak. That is, it would be around 500 hours and in the 10 meter per second. And the power calculation, power in the wind, the kinetic energy of the wind flowing across the wind turbine is used to drive electrical energy from the wind. It can be calculated with either of rho v cube into a in watts. The unit would be in watts. The wind speed increases by a factor of 2. The power output would be increased by a factor of 8. And the power is proportional to the area. The large wind turbines will convert more power from the wind. The wind power also depends on the density of the air, and by applying the density, we know the value of the density, which varies under different condition. When it was under static, that is whether it might be under standard temperature, that is 25 degrees Celsius, and standard pressure, that is 760 mm per mercury. And with that we have one peculiar question. I'll ask one particular question. See, under standard temperature and pressure, that is 760 mm per mercury, the air density is 1.27 and kg per meter cube. By applying this in the above formula, that is 1 by 2 rho v cube into a, the 1 by 2 into 1.27 becomes 0.6. Therefore, P is equal to, that is power is equal to power in the wind is equal to 0.6 V cube into A, and it is in the watt. And with these, the air pressure, and what was the man's normal blood pressure? What was the blood pressure of the human being, healthy human being? What was the
Atmospheric pressure, sir.
yes, pressure, blood pressure.
Atmospheric pressure.
No. Atmospheric pressure I have already given here. I am asking about humans, normal healthy human being pressure, blood pressure.
120 over 80.
Yes, little louder.
120.
Yes,
mm per
fine.
H.
Okay, let it be 120 mm per mercury,
120 by 80.
Yes, we can consider it as 120. See, there is a fluid. There is a tunnel, there is a tube, there is a hose, and there is a fluid flowing with a pressure of 120 mm per mercury, and the atmospheric pressure is 760 mm per mercury, and there is a leakage in the tube. What happens? Whether the atmospheric pressure goes inside or the liquid will come out? Yes, go ahead. What happens? As in, there is a tunnel. inside the tunnel you have the liquid with a pressure of 120 mm per mercury. The tube is surrounded by the atmospheric air which has a pressure of 760 mm per mercury. What happens when there is a leak in the tunnel, leak in the tube, leak in the hose? What happens? Anyone?
The water will come out, sir, because of the air opening of the air.
But the flow has to occur from the larger pressure. Yes.
Like if the tube is open, sir, and there's a hole, then it will come out. If the tube is closed and there's a hole, it will not come out.
There won't be any there is a point, there is a hole, and what happens? The air will flow inside, or the water will come outside. The liquid will come outside, or air will go inside.
Air will go inside, sir.
Yes, who said?
Arun Prabhakar.
Sir,
because pressure where I2 low pressure goes, sir. So outside 760 mm HG and inside 120. So airflow.
Yes, it was the scenario. It was the scenario. But what happens in the case of any injury with a human being? What happens? Arun Prabhakar, when there is an injury, what happens?
Yes, sir.
Why it is so? Any idea? In the veins, in the human beings, in the veins, there is a pressure with the 120 mm per mercury. Why it is so? Why it is so? Don't think big. It is very simple, very tiny question. It is. Don't think technically. It won't be a big technical question. Any idea? Any idea from anyone? Okay, think over the issue. We'll discuss at the end. At the end, we'll discuss. See, this was the conversion of wind power. The wind power converts the energy of the wind into electrical energy and converts the airflow into mechanical motion and gives the electrical power. And there are several types of wind turbines which converts useful energy. There, one is propeller type, multi-type, 7As, and ratios. And this is what we have seen earlier. The tip speed ratio is given by dividing the speed of the tip of the turbine blades by speed of the wind. For example, 20 mph wind is blowing on a wind turbine, and the tip of the blade are around 80 mph meter per hour. Then the tip speed ratio, this is not the ratio is 80 by 40, which is equal to efficiency of the wind power conversion. The higher the change in the kinetic energy, larger will be the power conversion. And this efficiency term in wind energy technology is referred as coefficient of performance. And the coefficient of performance is an important measure, that is CP, which is defined the ratio, that is the actual power output from a wind machine, which is divided by the availability of wind power, and that is the real wind power by the calculated one. And the actual wind turbine converts wind energy at lower efficiency than given by the Betz limit. We have the limits which is proposed with the Betz due to various losses, drag on the blade, swivel impacted to the airflow by the rotor, etc. This is true for all wind turbine designs, and the practical wind turbine have CP which is less than the Betz limit. And the tip speed ratio would be lambda is defined as the ratio of the speed of rotor blade tip to the undistributed wind speed, and undistributed wind speed is the speed of wind away from the machine. The tip speed ratio can be calculated with the aid of angular speed, the multiplication of angular speed, and the radius of the rotor with the velocity. The efficiency of the wind turbine increases with the increase of the wind speed, but decreases with mm, the high speed. See, omega angular speed and radius of the rotor is directly proportional, and V is directly proportional, and this is what the coefficient of performance as the function of the tip speed ratio for the propeller and the multiplied Venus or Derichius wind turbine. The maximum possible wind turbine efficiency is also shown in that is Betz limit is also shown. See, we will take it from example tip speed ratio. The Betz limit is given here, and the 59 percentage, and tip speed ratio. See, let it be this what 1, 2, and 3, 4, and when there is a 4 tip ratio, then these coefficient of performance should be 3.3 or 3.4, 0.34 for the Derichius. For 7 years, see the tip ratio is 0.5, then for the COP should be equal to 0.2. When it has the multi-blade, then it is equal to 3.5. And for the 2 and 3 blade propeller type, when it is 7, that is 6, the COP is equal to 4.5. This is what the maximum COP of the 2 and 3 blade propeller type. And the actual power output versus wind speed, that is in meter per second curve of wind turbine having the rating power and wind speed of 100 kilowatt and 14 meter per second, and respective and curtain speed of 3 meter per second and cutoff wind speed of 17 meter per second. See here the actual power output versus wind speed curve. Having the rating power of the wind speed is, if the rating power of wind speed is 100 kilowatt, then and 14 kilometer per second of wind speed, the cutoff would be 17 meter per second wind speed, and this was the other example, that is the power and energy of 100 kilowatt rated wind machine for a given distribution wind speed, the number of hours per year. And these data collected from a paper, and anyway when time permits we'll disseminate those contents, and see the worldwide wind installation capabilities, and this what the top 10 countries with the installed wind power capacity. And yes, at the top concerning 2018 megawatt, it was 25,170 megawatt, and we were in the fourth place, that is 9,645 megawatt during 2008. And wind turbine sizing system, and that's all about the wind turbines. And do you have any clarification with these contents? Any doubts? Any doubts?
No, sir.
Yeah, Maitreyan, what was the timetable, tomorrow timetable?
Sir, I think it's Tuesdays or Monday.
It's a Monday, sir.
Yes, sir. It's Tuesday's timetable, sir.
Tuesday. Okay.
Monday's
Okay.
timetable, sir.
Monday.
Monday's timetable, sir.
Okay. If any feasibility for conducting classes, if try to allocate one class, because we were last one class during last week, and
So we have our physics CT tomorrow. So can I allot it some other day?
yes, it is not. There won't be any urge. You finish it off
Okay,
all
sir.
the CDs first.
Okay, sir.
But the thing is, you tell me a day earlier.
Okay, sir.
Yes, Josna. Okay, we'll meet in the next week's Thursday. We'll meet. And concerning your examinations, that is, we have 24th between 3 to 5, and be in touch. Refresh the contents with the be uh, with the WhatsApp. I'll share the contents related to examinations. Any doubts, you post a message, and preferably the Google Classroom would be the platform, and be ready for your examinations. And the content which was disseminated till today would be the syllabus, and probably 25 marks with 1 hour. Anyway, those contents I'll disseminate very soon. Thank you. We'll meet Monday around 3 o'clock. We'll meet.
Thank you, sir.
Any
Thank you,
doubt,
sir.
you post it in the group. Thank you.
Thank you, sir.
Thank you, sir.
Thank you,
Thank
sir.
you.
Thank you, sir.
Thank you, sir.
Thank you, sir.